Good morning, dear children. Next is HOTS, Roman 10. This question is from the chapter Electricity. This is on page number 57. And dear children, we are into problem solving series. So the HOTS question, Roman number 10. The question number 1 is two resistors. Let me read out the question first. Two resistors when connected in parallel give the resultant resistance of 2 ohm. 2 ohm, but when connected in series the effective resistance becomes 9 ohm. Calculate the value of each resistance. This is the question. So here we have two resistors, right? Two resistors. Okay, shall I write here? Okay, R1 and R2. We have two resistors whose resistance are R1 and R2. Now when connected in parallel, we know this equation. That means 1 by Rp equal to 1 by R1 plus 1 by R2. So this is the equation. That means 1 by R1 plus 1 by R2 is equal to, what is the effective resistance here? 2. So 1 by 2. Instead of Rp, we can put 2 here. So this can be equation 1, right? And when these are connected in series, now we know this equation. R1 plus R2 is equal to effective resistance. That means RS connected in series. That's why I put the symbol RS here. Connected in parallel, that's why I put RP here. Okay. R1 plus R2 is equal to RS. And it is given. The data is R1 plus R2 is equal to how much? It is 9 ohm. So this is equation 2. The question is calculate the value of each resistance. Now, if this is a condition, what is the value of R1, R2? So, let us start with the equation 2, right? It's simple. So, R1 plus R2 is equal to, that means from equation 2, R1 plus R2 equal to 9. So, R1 equal to 9 minus R2, right? R1 is equal to 9 minus R2. Now we can put this put the value or apply the value of R1 in equation 1. 1 by, instead of R1, we can put 9 by 9 minus R2. Sorry, 1 by 9 minus R2, because R1 is equal to 9 by 9. R1 equal to 9 minus R2. So we put a 9 minus R2 in place of R1 in this equation 1. 1 by 9 minus R2 plus 1 by R2 equal to 1 by 2. Taking the LCM, 9 minus R2 into R2. This is LCM. Here R2 plus 9 minus R2 into 1. So 9 minus R2 equal to 1 by 2. Is that right? Plus R2 and minus R2, we can cancel here. So the answer is 9 by 9 minus R2 into R2 equal to 1 by 2. Cross multiplication. 9 into 2. 9 into 2 equal to 1 into 9 minus R2 into R2. Okay. Shall I put a line here? Okay, see. So 9 into 2 is, it is 18 equal to 9 minus R2. 1 into any number is that number. So just ignore this one, because 1 into this number, it gives this number only. 1 can be ignored here. So R2 into 9 is 9R2 minus R2 into R2 is R2 square. R2 square, right? Taking all this on left side, this right hand side, the right hand side portion, now I take this on left side. So minus R2 square becomes plus R2 square. This plus 9 R2 becomes minus 9 R2. Already it is 18 equal to 0. So this is a quadratic equation. Now you know how to solve this equation. That means two numbers the product of two numbers must be 18 and the sum of two numbers is minus 9. So what are their numbers? If you have an equation like this, then you must understand this portion. This is the product of two numbers and minus 9 is the sum of two numbers. So those two numbers for which the product is 18 and the sum is minus 9. What are the numbers? That is minus 6 and minus 3, right? Minus 6 minus 3 becomes minus 9. Minus 6 into minus 3 is plus 18. So R2 square minus 6 R2 minus 3 R2 plus 18. That means minus 6 into minus 3. Okay, 18. I put 18 here. So the answer is R2 minus 6 into R2 minus 3 equal to 0. So R2 may be 6 or R2 may be 3. So it can be 6 or 3. Okay, just for the calculation. If R2 is 6, now put in equation 2 here. Okay, now you put the value of R2 in equation 2. What do you get? R1 plus 6 equal to 9. So R1 is 9 minus 6 equal to 3. When R2 becomes 6, R1 is 3. When R2 is 3, put 3 here. R1 plus 3 equal to 9. So R1 equal to 9 minus 3 equal to 6. So when R2 is 6, R1 is 3. When R2 is 3, R1 is 6. So this is answer. Okay. So the two resistors, value of resistance of two resistors are R1 and R2 maybe 6 and 3. Or you can write 3 and 6. Both are right. R1 and R2 are 6 and 3 ohms. Okay. You put ohm here. Simply so. Hope you understood. Thank you so much for listening to the whole video.